In this episode of my many episodes, I will show a special IC. And if you are familiar with my channel and a regular viewer, this one is not very new to you. It says it crystal oscillator, but this one does indeed have a lot of connections. I've made a video about it. You may find it if you look for it. You probably will find it. Back then I told you I have more of these, not specifically this one, but special crystal oscillators. If you go to store pages, you can buy many crystal oscillators in different sizes and frequencies and shapes. But it's very uncommon that you can buy one where you have a pin on the actual component that allows you to broadcast audio. So I bought a collection of random crystals that were mostly passive crystals, but there were also some active components inside the package. And one of them was this IC, but this is not the only thing. This round thingy that looks like a transistor, but it isn't a transistor, it's a crystal, was there too. So this one was together with the other one, and it was held in a small plastic thingy, like an inch in length, half an inch width, and half an inch high. The actual thing was a bit smaller, but you get an idea. So both were held inside this plastic thingy, but they were not connected to each other. There were two individual components, and it had a part number on it, and it also said 10.0, lots of 0 megahertz. I'm not sure if it really said megahertz or M point. Usually you can also say M point to get a hint what is the frequency. And if you look at the component, you will read the printing, and this is what it has. I think this is the old Siemens company sign. Then there is a circle inside the plastic thingy. It's a bit deep, but it's not too deep, and there is this sign inside the circle, and it says S234 on the top. If you look, you can see this blue thingy. That's the lower side, the belly. This is what it says. It says 23, then it says A, and this looks like the letter I, but it's just like a line. I'm not sure if they mean it's the letter I, it's a line thingy, and someone has written A over it with a blue color. So this is what it's on the underside or the belly. As you can imagine, I'm playing around with these kind of things, and I didn't have a schematic for this thing. I'm not sure if there is a schematic available online, because this is obviously very old. I guess it's from the maybe early 80s. It already is oxidizing on the pins on the upper side where the housing is. On the lower side it's okay, but the upper side is starting to oxidize a bit. It's really antique and old. I should put it that you can see it. So I was hooking it up to electricity, and what did I do? Well, I know that most ICs these days are connected in a more or less standardized way, that the pin 4 is minus and the pin 8 is plus. This does not count for all ICs. There are a lot of ICs that have different pinouts. For example, the timer IC, where pin 4 is definitely not ground. Instead, pin 1 is ground on the timer. But that's not the topic. If you go to bigger ICs like CD4017, CD4060, you have a default pinout where pin 8 is always ground and pin 14 is always supply voltage. So I just thought, okay, this is like default thingy. So I hooked up ground to pin 4 and plus to pin 8. Of course, I was using a current limitation, because if I have it hooked up wrong, I could pop the IC, and this is the only one that I got. So I was very careful when trying to figure out what is the actual polarity of this thing. So the IC then got put into a solderless breadboard, but I still had the crystal and I had no schematic how to hook it up. What I did is I took the crystal literally and just held it to the connectors, just random, just playing around. I didn't expect it to work, but the second attempt it started to oscillate and it started to transmit. So I figured it out. I'm trying to get this thingy inside the solderless breadboard, which is quite difficult because you can see that on this side here I have like 2 inch at least. Then there is a wall, and this is very narrow and very tight. Get it in there may take some time. Well, this is my third video that I take. I had one where I was like fiddling a minute to get it in, but it's very happy. I got it in there. The moment I plug it in, you can already see there is a signal coming from it. It's on the radio. You can see that the tuning LED is on, and this is the frequency, by the way, 10 megahertz. And it's transmitting. And I said, okay, I got it transmitting, but I want to transmit some audio. I want to transmit some music, some speech, whatever. And so I took my IC and just played around with it. And this is what I came up with. This is a very simple method of getting audio to it. So you can see it does look complicated, but trust me, it isn't complicated. It's just a lot of lines confusing you a bit, but don't be confused. Just look how the lines are connected and you will figure it out. Figure out that the pin 4 is ground, pin 8 is plus, and I'm hooking up audio via a 470 nanofarads cap to pin 5. The crystal connects between pin 2 and pin 6. I tried different frequencies. You can replace it. It does work. For example, if you have a crystal on a broadcast band, like the 49 meter Euro band, which is very common, you can put it in and it will also transmit on that frequency. It just happens to have a 10 megahertz crystal, which is belonging to the IC. Okay, now let's press play and hear the audio. That's the maximum volume I have all the way up. Very, very, very in the background is the audio. Now look at something. If I change the supply voltage, if I lower the supply voltage, I have added a resistor. The resistor drops the supply voltage from the IC. Now press play.
In Bestform. Der neue Mazda 6. Mehr Sportwagen.
A very simple and very not fancy way to get modulation to the IC is this circuit, and you have to get your supply voltage right. Spot on 3.6 volts or a bit more is too much, but connect it to 2 volts and it will not oscillate, it will not transmit. So like a regenerative receiver, you have to add a potentiometer in series with the supply voltage, get your supply voltage right, and it does do the AM transmitter thingy. It's not perfect, because of the voltage needs to be adjusted correctly, but also you could hear it from the radio, but keep in mind that the modulation level is very low. That means if I crank up the volume that is about as loud as a regular AM station, it starts to sound really bad and really distorted. If you run a low audio volume on your transmitter, it will heavily affect your range and not in a positive way. I figured this is just one way to get audio onto the IC, and I found this out more or less random, playing around with it. So I thought I need a better way to make this work. And this is the better way I came up with. This is the fancy circuit, if you want. And as you can see, I'm leaving pin 5 alone, no more audio on pin 5. Instead, I'm using pin 1. And this is also a thing I found out doing experiments. Like I said, I was just playing around with this. I don't have any goal for this, like this needs to be a project someone can rebuild, because this is a very special and rare component. How can you buy it? So I was just playing around. The cassette player was on, playing music, and I was having my connector and just trying the pins. Of course, I have a capacitor between my cassette player and my IC, so there's no DC flowing back into the cassette player, damaging either the cassette device or the IC itself. Just the audio is put in. When I connected it to pin 1, the thingy, I could, for a very short moment, hear the audio, hear it, but it disappeared like a half a second and it disappeared. So this told me, okay, the capacitor charges up, but if you get a certain voltage level on pin 1, it probably works. 10 minutes later, I figured it out. You have to add a variable resistor, a fixed resistor too, but I added a variable resistor. And if you have this one right, it now does produce a very good transmitting quality. Don't want to brag about it, but if you use the right capacitor value and the right audio processing, you can get it to sound as good as a regular AM station. This is how clear it sounds with this modification. Of course, not with this capacitor and not how cheap I have built it, but if you would put more effort into it, you could get it that way. The most important thing when it comes to AM transmitters is linearity. And this has a lot of linearity here. That means you can run very high modulation levels, and very high modulation levels give you a good audio quality and give you a good range. Okay, I'm going to show you the circuit now. I'm going to connect the audio source to pin 1. I'm not having the potentiometer and this resistor in the circuit. The resistor is on the solderless breadboard, but it's not connected. I will add this later so you will see the difference. I hope this one doesn't break because this one is very dodgy. I've removed it and put it back, and from all this, doing this again and again and again, it's very, it's close to breaking. I hope it will hold this clip long. Careful. It is going to give me one more chance to make this clip. Okay, it's in there, it's holding, but yeah, okay, so I will try to show you what happened when I was fiddling around. I will try to reproduce the effect. No guarantee it's going to work. It probably won't work, but maybe it will. So in my case, the transmitter was on, but now the capacitor is charged, and if I plug it in, it might work for a fraction of a second. So let's push play. Let's connect the power. And it doesn't work. Yeah, I was expecting that. I mean, like I said, this is to catch this moment where there is audio, but just for a very short time isn't that easy. But as you can hear, you can't hear any audio at all. Now let me add the device here, the variable resistor. And then
Was sagt denn der DFB dazu?
Kein Kommentar.
Was sagen Sie denn zu der E-Plus-Tarifautomatik?
Die Tarifautomatik bringt mich immer automatisch in den günstigsten Professional-Tarif. Monatlich, rückwirkend und kostenlos. Stimmt's?
Kein Kommentar.
E+. Und wann wechseln Sie?
so, okay, so music.
Bei Douglas.
Let's add bass.
Der Frühling macht die schönsten Geschenke.
Jetzt bei Douglas.
Yeah, you can't hear much of a other sound thingy.
Von Marco Polo. Erfrischend optimistisch. Ein energievoller Start in den Tag. Marco Polo Pure Morning.
Neu zu Ostern. Natürlich bei Douglas.
Sie behalten Ihre Rufnummer und bekommen 50 €.
It's working very well.
Sag ich doch.
E+.
If I tune here,
Viele versprechen es.
uh,
Das kann es beweisen. 73% aller.
this is now the resistor basically to ground. So if you pull this pin too much to 0 volts, no more signal. If you allow the pin some voltage, as you can hear some of it starts to transmit, but it's not clear. Listen. Now I line it perfectly.
Qualität. Expert. Preiswert und kompetent.
Durchfall kommt immer ungelegen, deshalb gibt es jetzt Imodium Akut Lingual. Sie brauchen kein Wasser. Die praktischen kleinen Plättchen zergehen einfach im Mund, sekundenschnell. Ich glaube, er stimmt zu. Imodium Akut Lingual. Und der Tag gehört dir.
That's the end of this clip. I wanted to show you the special IC. As you can see, here it is with the crystal that came with it and the IC, and you can make it an AM transmitter on shortwave. I haven't tested if it runs on AM band low frequencies. I probably could modify it to get it that low in frequency, but there's no need for it. This is just another one. 3 parts are there. First one was the TTL oscillator, first one TTL, second one this one, and the other one I have one more left of these special ICs, which is different than this one, but it's also special in its own way. Yeah, this is another one of the special crystal oscillator ICs I wanted to show you. As always, thank you for watching my videos. Have a good time. Best greetings, Stefan.